When the space between the galaxies stretched in a veiled way, it would exert a repulsive effect between them, at first. A kind of antigravity force that could not be noticed, due to the simultaneous contraction of time. This repulsive effect should be linked to the increase in the potential elastic energy in the expansionary phase. If space stretched out of control, time would have to contract in a complementary way. The relative movement would tend to disappear as soon as time lost its characteristics of direct measurability. Physics tells us that potential energy in the observable universe would be zero at infinity. Note that the potential energy would not need to reach infinity to completely cancel itself out. For our memory, it would be enough for time to contract beyond certain limits, which would still remain very far from absolute zero. Likewise, in the expansionary phase, the potential energy could not be maximum at infinity, as it would also have its module delimited by time itself. That is the importance of our points of view. The limits of our horizon of observable events would be dictated only by the contraction of time. This, as everything indicates, would occur at the subatomic level, and not in the macrostructure of the universe. Photons of light would have taken our sensory perception of time to subliminal levels. The space would tend to flatten out on its original dimensions, which are the width and the length, with the flattening tendency being suspended to infinity. Outside, galaxies should return to their position of static equilibrium, which, in our view, will never be reached. It is that our memory could not act out of time. Thus, the uncertainty of the position of the light sources seems to be preserving our own memory. After the apparent inversion in the direction of its arrow, promoted by the scattering of the light of the stars next to the observer in the present, time would have started to expand continuously in the direction of our past. With the participation of time, the observer could finally register, in a lagged way, the relative movement of distance between the galaxies. This expansionary movement would be added by acceleration, which would be a characteristic of the opposite phase, or by contraction of space. This space would continue to act on the masses, without being noticed by the observer, generating inertia from the vacuum. We have a tendency to conclude that the space would follow that behavior model, predicted in the harmonic oscillator, represented in a mass spring set, behaving in the same way as an elastic strip. Obeying this model, if the post-Big Bang universe were expanding in real time, the potential energy should gradually increase, accompanied by a slowdown. The force of the spring would point in the opposite direction to that of its stretching. In this model, if we put the 0 point of time in the position of the singularity of the Big Bang, the galaxy should be attracted and collapse, sooner or later. For that not to happen, the 0 point of time would have to have been placed virtually in our position, in the present, followed by the inversion in the direction of the arrow of time. An expansionary movement, taking place in real time, would not be compatible with what happens in space-time, because here, the potential energy would be zero and infinity, not maximum. As the potential energy would exert an attractive force between the celestial bodies in our past, it would be negative at finite distances. The spring of space would be at rest in infinity, and would start to contract from there. There would be no theoretical support for the existence of a spring stretching phase in real time, or that could be directly measured. The potential energy would gradually decrease as the distance between two attracting bodies decreased, accompanied by an acceleration of movement. it is seen that the two events, the distance between galaxies and the continuous acceleration of their movement, belong to independent phases, which would mutually exclude each other. From the premise that the movement observable by our memory would occur in time and not in space, the dilation of time could promote the latent observation of the distance between galaxies, which would have occurred outside of time that we can directly measure. That is, by excluding direct access to time in our future. This would contradict the claim that the radiation from the Big Bang, as well as that emitted by distant galaxies, is coming from our past. It would be the expansion of time in the observable universe that would allow us to conclude, indirectly, that space would be expanding simultaneously outside of here, but there would be no way to demonstrate this in practice. One can raise, for example, the hypothesis that the secondary and continuous acceleration would not be occurring due to the contraction of the space spring. It would be a response to the further stretching of the spring, outside space-time, or outside what we see directly. This was due to the capacity of space to generate inertia in a veiled way, and without depending on the direct influence of the masses. An interesting obstacle, which would have been imposed on our subjective evaluation, is the finding that during the expansionary phase, there would be a complementary contraction of time. Thus, if the arrow of time always points to the future, as is accepted, this phase could not be remembered in our present, because the future has not yet happened. The impression that remains is that, as soon as the radiation reached our position on Earth, while the Earth entered the future light cone at the event, there would be an apparent inversion in the direction of the arrow of time, starting to point continuously to our past. Unexpectedly, we continue to assume that the speed of light would be accompanied by the contraction of time in the direction of our event horizon. This would have been passed on to galaxies in the form of accelerating their movement. However, they would seem to move away from each other with increasing speeds due to the direct action of time expansion. It is that inside the observable universe, the spring of space would always be contracting, according to the definition of gravity. The potential energy would be zero at infinity, and not maximum as predicted in the inflationary phase, decreasing with decreasing distances. Better than saying that space would contract in here, then, it would be saying that it would be stretching less, outside. This would maintain the disorder of the system, and assign gravity the secondary character of a restorative force. As the potential energy would always be negative or attractive in the observable universe, it would characterize a movement back to the two-dimensional center of space, a position that could never be reached. This movement would be suspended to infinity. To reach this conclusion, we would have to give due attention to our points of view, because everything we see is dependent on our memory. And our memory would not work without the concurrence of time.